Regarding the construction of the Brooklyn Bridge, our presentation is based on John Roebling's invention of the wire rope through his work on the Pennsylvania Canal. Before we get too deep into the subject of ropes, let us look at the history behind the entirety of this innovation. The Industrial Revolution was a period of transition to new manufacturing processes and technologies, which allowed mass production of goods. This prompted the need for more efficient and effective methods of transporting large quantities of goods and materials. With the railway system still in its infancy, canals were the obvious choice for fast and cheap transportation. One of the first canals built in the U.S. was the Erie Canal in New York. This canal improved trade and reduced travel time so much that it started pulling commerce away from other states. In response, many other states, including Pennsylvania, launched projects to build canal systems that could compete with New York's Erie Canal. Construction of the Pennsylvania Canal System began in 1826. It was designed to be a vast network of canals spanning hundreds of miles that connected Pennsylvania's largest cities like Philadelphia and Pittsburgh. The goal of the canal system was to broaden lines of transportation and increase commerce as the state grew. It connected Pennsylvania's rural communities to the growing urban population and factories. One such rural community was Saxonburg, home to agrarian and engineer John A. Roebling. Displeased with his life on the farm, Roebling decided to return to a career in engineering and soon became the supervisor for the railroad connecting two canals over the Allegheny Mountains. The railroad was used to carry boats from one canal over the Allegheny Mountains to another canal so that the line of transportation could remain open. Boats had to be removed from the canal, split into two sections, and hauled up the mountainside via railroad tracks and stationary steam engines. Cars carrying the boats traveled up a series of inclined planes, pulled up and down by a long loop of thick hemp rope, which could be up to 7 centimeters thick. At the plateaus between inclines, mules dragged the boats horizontally before lowering them onto another inclined plane. Utilization of hemp rope was extremely important in this process. These hemp ropes were very expensive and broke frequently, causing them to be constantly replaced. The consequences of using such an unreliable and weak material as hemp for ropes became clear to Roebling when he witnessed the death of two of his workers after the hemp ropes snapped, releasing the heavy cargo they were carrying. Using his engineering expertise, Roebling devised a way to create a stronger and more reliable rope out of metal wiring. His wire rope was stronger, lighter, and much more durable, lasting several years instead of a season or two. The wire rope was also more elastic than hemp and could withstand a sudden heavy load without breaking. Even though the concept of a wire rope had existed since the early 1830s, its origin of use in the U.S. and in suspension bridges began with John Roebling. In 1842, he patented a new way to manufacture wire ropes using a specific machine which he designed. Roebling's technique included applying uniform tension to all wires and strands by attaching weights to their ends, and preventing twisting of the fibers through attachment of swivels to the wire and strand tips during manufacturing. Roebling's patent focused on the wrapping machine, as illustrated in this slide, that he invented to produce his wire ropes. The properties of steel rope made it an ideal replacement for hemp rope as less material was needed for the same strength. The smaller area of contact between the rope and machinery lessens drag on the rope, decreasing the amount of work and energy used by pulling of the rope itself. Due to the strength of wire rope, it was also less susceptible to sudden breakage, making it more reliable. Roebling's patented wire rope was first used in 1844 in a revolutionary wire suspension system to rebuild the Allegheny Aqueduct. This aqueduct connected the canal system to the city of Pittsburgh, providing a waterway to the factories. Roebling was granted $62,000 to remove the remains of the broken aqueduct, repair the masonry towers, and to construct a new aqueduct using the wire rope suspension system. Roebling also introduced a new method of building suspension bridges, using fewer but larger, stronger cables, which would allow the structure to sustain both lateral and vertical loads. The common method for suspension at the time was the French system, which used iron chains to suspend the bridge. A large amount of chains had to be used because each chain was only as strong as its individual links. By using steel ropes instead of chain links on bridges, Roebling benefited from a balanced tension system. Each wire sustained relatively the same amount of tension, so there were essentially no pressure points on the rope. Previous bridges with chain links had their weight unevenly distributed on the supporting chains that often had faulty links. While steel wire ropes are larger and heavier per strand than the chains, fewer ropes were needed, which dramatically decreased the overall weight of the bridge. This allowed the structure to support a heavier live load of materials, as less of the occupying force was spent supporting the bridge itself. Roebling further improved the bridge building process by spinning the required cables on site. Previously, all wires were spun elsewhere and dragged onto the construction site. This would distort the cables and ultimately cause tension to be distributed unequally. Spinning the cables on site and directly into the position they were to be used ensured that individual wires of the final product would all bear weight equally. Roebling's innovation in wire rope production allowed him to eventually construct what would be the longest suspension bridge in the world. The Brooklyn Bridge spans the East River, connecting the boroughs of Brooklyn and Manhattan. It was the first steel cable suspension bridge ever built, and became the precedent for the modern suspension bridges built today. The same technique was used in several great bridges, including the Williamsburg, Manhattan, George Washington, and Golden Gate bridges. Many technological advancements were made possible by Roebling steel wire ropes. The Roebling and Sons company went on to manufacture elevator rope, hoisting wires, safety slings, and insulated wires. Other uses for metal wires include, but are not limited to, telegraph and telephone cables, electrical wires, and cable car lines.